Right here we're looking at morphine. Okay. We are given grams of different elements of morphine instead of percentages. So here we can go ahead and basically start at step 2 in our process. Basically, if you look here, see how we were given percentages and we had to assume 100 grams to put them into grams. If they go ahead and give you masses, you can start at this point. So this is basically step 1. Step 2 is to do this math. If you're given grams, if you're given masses, you can go ahead and start by converting those masses to moles. So you don't have to do anything different. So we get 17.9 grams of carbon. Let's use different colors, just kind of alternate. 1.680 grams of hydrogen. All right. 4.225 grams of oxygen, not carbon. And 1.228 grams of nitrogen. Okay. I'm going to go from grams to moles for carbon. So 1 mole of carbon is 12.01 grams of carbon. That'll give me moles of carbon. Okay, do the same thing for hydrogen. 1 mole of hydrogen is 1.01 grams of hydrogen. That'll give me moles of hydrogen. For oxygen, I know that 1 mole of oxygen is 16 grams of oxygen. That'll give me moles of oxygen. And for nitrogen, I know that 1 mole of nitrogen is 14.01 grams of nitrogen. That'll give me moles of nitrogen. Okay, so let's go ahead and do the math. So we get 17.9 divided by 12.01. I'm going to record this to 4 decimal places, so 1.4904 moles. For hydrogen, got 1.680 or 1.68 divided by 1.01. So for 4 decimal places, that's 1.6634 moles of hydrogen. For oxygen, I'm going to take 4.225 divided by 16 to give me 0.2641 moles of oxygen. And for nitrogen, I'm going to take 1.228 and divide it by 14.01 to give me 0.0877. Go ahead and just do that. Okay. Now, at this point, these are the number of moles in my sample. I can find their relationship to each other by dividing each by the lowest. So I'm going to divide everything by 0.0877. Well, I don't know why I'm not putting zeros in front of that one. Okay. This is going to give me 1 mole of nitrogen. Okay. Here I've got 0.2641 divided by 0.0877. This gives me 3. I'm going to go ahead and just do these in green. 3 moles of oxygen. Okay. We've got 1.6634 divided by 0.0877. This gives me 19 moles of carbon, or hydrogen. And for carbon, I've got, what the crap, 1.4904 divided by 0.0877. This gives me 17 moles of carbon. So this is the relationship of moles to each other. Go ahead and you can write your formula just putting them all in the order you're given. Now, if you were to look up the formula for morphine, a lot of the times they'll put the nitrogen before the oxygen, but it doesn't really matter because you're just showing the relationships there. So go ahead and your empirical formula for morphine then would be C17, and again, just put them in the order that you were given in the problem. So C17, H19, O3, N, or NO3, it doesn't really matter. Okay, there's your empirical formula for morphine.